Hi, this is the Tiny Clock breadboard prototype, and this is C Darcy's final in-case version. Both versions display the time for a fixed number of seconds, and then the date. The breadboard prototype shows the date in a numerical fashion, with a decimal instead of the flashing colon, whereas the final version continues flashing the colon, but uses letters for the month to distinguish that it's the date. The breadboard version also has a feature to change brightness based on ambient light. When this LDR is covered, the brightness is decreased. When the LDR receives more light, the brightness is increased. This means that the clock will not be blindingly bright in the dark. So let's get into how it works. The first thing to note is that the whole display operates on the basis of persistence of vision. This display can only really show one digit at a time, so it shows each digit in rapid succession, and that makes it seem like all the digits are on at the same time. Due to limited input and output, 2 shift registers are utilized. Now to the code. First, I2C is initialized using the TinyWireM library, and the I/O is set using data direction register B. The latch, clock, data, and I2C clock pins are set as outputs. Within the loop function, the number of milliseconds is stored to a variable called time buffer. Then, in a 12-second loop, the time is shown for 10 seconds and the date for 2. After 10 seconds, a variable called date is set to 0, which toggles the date and time. The first thing done when displaying the time or date is setting the brightness based on an LDR in a voltage divider configuration connected to the clock pin due to limited I/O. To do this, the clock pin is set to an input. Then the voltage is read and scaled to 8 bits and written to the output enable pin of the shift register. Finally, the clock pin is set back to an output. Once the brightness is set, the time or date is written to a buffer. To do this, a wire conversation is started with the RTC. Then, if date is 1, the MCU starts reading from register 1, which is time, but if date is 0, it reads from register 4, which is date. Next, it ends the transmission and requests 2 bytes, either minutes and hours or date and month. Then, the MCU waits until the data has been placed into the data buffer. The high and low bytes are then stored into variables and parsed into a buffer 1 digit at a time. With the data in the buffer, the correct values are written to the shift registers using a for loop which runs through an iteration for each digit. First, dec bit, which controls the decimal on bit 7, is activated if date is 0 and dig is 2. Next, the cathodes and anodes are shifted out using the light disp function. The anode is simply the digit, or 1 shifted left dig times, and compared to the date to disable the colon when showing the date. Next, the cathodes are shifted out. An array-based segment map called numbers is given the values stored in the buffer, which maps the segments to a digit. It's also compared to dec bit to turn on the decimal when showing the date. The whole cathodes are inverted since a path to ground activates a segment. This entire process is repeated many times per second. Thanks for watching. That's how the tiny clock works.